All right, so when we are given an equation or a formula written in mathematical symbols, which is just algebra, we are normally asked to find one value or symbol. We isolate the variable by doing mathematical functions to both sides of the equation. So we'll just do some general stuff to begin with. But often in physics, sometimes it can be very efficient to figure out, look at your formula, figure out what thing are you trying to find, and rearrange your formula first. Okay? It's better to develop this skill now, because by the time we get to physics 30, it is much more efficient to rearrange your formula first, because you can often see that there's things that you can cross off or eliminate, and that you don't need to punch into your calculator. Okay? All right, so we'll start with something very simple to begin with. Identify the unknown you are trying to isolate. What am I trying to isolate here?
X.
X. Okay, that's my X. Isolate the chunk with the unknown doing the opposite math function on both sides. So this is a part of a whole chunk, so I want to get that chunk all by itself. So if I have 3x squared plus 9 is equal to 12, I need to get rid of the plus 9 because it is attached to the chunk that I want to isolate. So my chunk is added, it has plus 9, so what's the opposite to minus 9 on the other side, or subtract 9, yeah? Okay, so now I have my subtract 9, subtract 9. So the opposite is done to both sides of the equation. So now this is no longer needed on that side. So I can rewrite the equation as 3x squared is equal to 12 minus 9. So now we can simplify that. So what is 12 minus 9? Very good. Okay, so now we have 3x squared is equal to 3. Okay, so we have simplified it. We've broken our chunk down. Oh, it's on this side. Multiply, divide, or square root, square, etc. to do the opposite math function on both sides to now isolate the unknown completely. Because before we just isolated the unknown that was in a chunk. So now we have it in its chunk by itself. Now we have to solve. Okay? So what do I need to do? Divide by 3, okay? So I have my 3x squared is equal to 3. So I want to divide by 3 to both sides. So this is the same as x squared is equal to 1. So now how do I solve for x? I square root now, okay? So since the x is squared, to solve for x, I square root each side. So now I go the square root of x squared is equal to the square root of 1. So now x is equal to 1. So now, let's take, these are formulas that are used in physics, okay? Like this means like centripetal acceleration, okay? So if we're using a centripetal acceleration formula, hi?
How do you spell that?
Spell it?
Yeah, because I want to maybe get a note.
Oh no, it's irrelevant at this point. Don't worry about it. When we actually use that formula for centripetal acceleration, it'll be there. Well, I'll tell you. So centripetal, I think, acceleration. So like when something is moving in a circle, and you kind of feel that pull from moving really fast in a circle, that's what it's. Yeah, exactly. Which is that times its mass, right? Because force equals mass times acceleration. anyways, okay, but say we're told we have to solve for the t in here, okay? So how am I going to rearrange this formula to solve for this big T, okay? I want to solve for that big T. So how can I do it? So right now, that T squared, the big T stands for period, that big T is on the bottom of a fraction. So how can I what should I do to work with that? Multiply, right? Yeah, okay. So now I'm going to go A, so it's, the C is like a subscript, so it's like centripetal acceleration, so A, C, little c, times by T squared is equal to 4 pi squared R. Okay? I want to get T all by itself, so what is attached to it right now that I can deal with first? My centripetal acceleration, I can get rid of that first, okay? So right now my variable that I want to solve for is multiplied by something, so what should I do to that? Divide it, okay? So divide this side by A subscript C, divide this side by A subscript C. So I can cross those off now. And sometimes, if you want to, you can rewrite it again. T squared is equal to 4 pi squared R over AC. As you continue working on it, you will be able to make shortcuts, but we can just rewrite the whole thing. So now how do I want to solve for T? What's my last step? Square root it, yeah. So square root each side. So now I'm left with T is equal to the square root of 4 pi squared R over AC. Okay, so that's then, I would take my information about my radius and my centripetal acceleration, I can put it into that formula, find period. Okay. Yeah?
So when you do that, you see how pi squared, can you take pi out of the, because it's squared and
you'd have to square root all the variables.
Oh, yes. It would have to be like T is equal to, if you took it out, go like that, you mean?
Yeah.
Pi times by the square root of 4
and then you
times.
bracket.
Yeah. So you wouldn't have to. I would just leave it, but yeah, it's possible. Okay. So what was that valve for? Was that for? What time is it? Okay, so we still have that. So that must have been like a junior high valve. Okay.
Oh, probably after the first period.
Okay. You didn't hear about it?
No, it always happens. I never hear about it.
You're funny. Okay. So here is a formula that deals with the speed, distance, time of an acceleration of an object moving. So if you're told some certain variables and you're asked to find VI, which means initial velocity, okay? So now let's rearrange the formula to solve, say we're trying to solve for VI. Okay, so the V little I, that's one thing. So it's like initial velocity. So if I'm trying to solve for my VI, ooh, my board is a little bit off here. If I'm trying to solve for my VI, right now it's attached to this chunk with a T, which is added to another big chunk. So if I need to get rid of my things that I can add or subtract, do that first, right? Am I going too slow, or am I doing this, is this too slow and you guys are like, okay, move on, or is it, are we okay? Okay, you can tell me if I need to speed up or slow down. Okay. All right, so it's added to another big chunk, so what's the opposite of adding? Subtracting, so we need to subtract that whole big chunk. Okay, so we want to go d minus 1/2 at squared, because that's this whole chunk, is equal to vi times t and then I have my plus half 8. I'm going to rewrite this because I'm going to run out of room. Just stop for a second. Okay. So d minus half at squared. Okay. So what I did, okay, was we had our d is equal to VIT plus half AT squared. I minused half AT squared on this side, and I minused half AT squared on this side. Do you see that? So I minus that whole chunk on each side. So what I can do now is this chunk is a positive one, this is negative, so these will cancel each other out. It just looks a little bit more complex because it's a big chunk, right? It's not just like plus 3 or something. There's more going on there. So let's simplify it. Let's rewrite it so it's a little bit simpler. So what we have left is d minus half AT squared is equal to VI times by t. Okay, now we have to think to ourselves again, what was I looking for? My VI. So VI is attached to t, so I can divide everything by t. Okay? So now we divide the whole thing by t, the whole thing by t. Now, you could see that you could put the 2 on the bottom of the fraction, and that would be appropriate as well. But anyways, we'll cross off the t's here now. So now I have d is minus by half AT squared, all divided by t, is equal to VI. Okay? Or this would also be appropriate to write it like this. D minus AT squared divided by 2t equals VI. Oh, no, actually, never mind. Ignore that. I'm not confident about that. Okay, so now I think on the back side you have your practice problems.